So let's do a completing the square problem. We have this quadratic. We're going to use the completing the square method. What we have to do is look at the x term, that is this term here, the one in the middle, the term with a single x, and we must take only the coefficient of that, the coefficient being the -6 part. First thing we have to do is we have to halve it. So we have to find what a half of that is, and a half of -6 is -3. Then we have to square that, and -3 squared is 9, and then we add that and we take it away. Now let's see what we now end up looking like. If we have our whole equation, we have y equals the x squared stays the same as it was before, the -6x stays the same as it was before, and now we bring in the +9 and the -9 part of it. So I plus the 9 and minus the 9, and my +1 from the original is still on the end there. So you can see I haven't changed its value in any way. I've just added 9 and taken 9 away, so that's 0. Nothing changed in its value, but it just changes the way that it looks. The whole point of doing that was so that I can get these first three terms. So that's the ones from those first three terms. Now if I've done that all correctly, first three will form a perfect square. So we should get something now that looks like y equals x something all squared. It'll be a perfect square. The something that goes in there is the original part that you halved. When you halved the coefficient of x, that's the thing that will go in to the bracket here. So that will be -3. On the end here we now have, so that's the first three terms all done, we've got -9 plus 1, which is -8 for the last part on the end. Once we've completed the square, we have it in what is sometimes called turning point form, and you can find the turning point of this quadratic will be at the point 3 - 8. But there we go. That's the completing the square method.